Hi, welcome to lesson number 4, module 6 of the Apache Spark and Scala course. So in this particular lesson, we will be looking at the life cycle of a streaming application. Now before we proceed, let's have a quick recap of the last lesson. So in the last lesson, we learned about the Spark streaming architecture and what exactly is meant by a D stream. And we also had a look at the concept of batches and demonstrated all these using a simple word count program. So in this lesson, we will understand the execution of streaming applications. We will understand how streaming applications are processed in a cluster. Now, just like any other type of Spark application, when Spark streaming runs, the work will be distributed among multiple worker nodes or slave machines. Now, as we are aware, this completely depends on the size of the cluster and the resources available to you, and there will be a machine which will be running the user driver code. Now remember, the driver is responsible for sending the business logic or your program logic to the workers. Now the driver will be contacting the executors on the worker nodes and launching tasks every certain interval. And the cluster can be on Yarn or Mesos or even Spark standalone. Now, what happens in case of Spark streaming is that the driver will run receiver as long as the data is coming. Now, remember, receiver is an entry point for the D stream. So you can have multiple types of receivers depending on from where you are pulling the streaming data. For example, if you are getting the data from Twitter, you can use a Twitter receiver. Or if you are getting the data from a Kafka cluster, you can have a Kafka receiver. However, please note that the receiver will be running on one of the worker node, and that starts receiving your data. Now, the driver program will run as long as the data is coming, and the receiver will get the data and store it as blocks in the main memory. These blocks are also replicated for high availability. So you can clearly see all these details in the diagram. So here you can see that the driver is running in a separate machine. Then we have one worker node having a receiver which accepts your data stream. And this data stream is divided into blocks and kept in memory. And then it is also replicated. Now let's see how the data gets processed. Now every batch interval, the driver will be launching tasks on the blocks that are available. So let's say you have created a streaming job which is going to count the number of elements, and let's say your batch is for 3 seconds or 5 seconds. Then based on the batch interval time, this count operation will be performed on all the data blocks. Now in this simple picture, you can see that the blocks are available on one machine and the replica is also there. But in the real life, the blocks will be distributed among multiple machines. And once your calculations are done, you can take an action such as storing the results into our data store or even displaying the results on the screen. Now let's have a look at an end-to-end view of a Spark streaming application. Now if you look at this diagram, this may feel very familiar to you because this diagram is taken from our RDD lesson and it is exactly similar. The only difference in here is that all the transformations that you are applying will be on the D streams rather than the underlying RDDs, but D stream is just an abstraction or a wrapper on top of the RDD. So first we have our streaming application and you have to write it, right? And then we have the Spark Streaming job scheduler plus job generation. So we have an input D stream, and then we have a directed acyclic graph of all the transformations that we are doing, which includes all the transformations and actions. And Spark will schedule this as a job, and then the individual DAG will be divided into multiple stages. We know that a stage is a set of tasks between any shuffle level of actions. So the DAGs will be comprised of stages, and you will have a Spark DAG scheduler for this. And then every interval, the tasks will be launched. So to wrap up in this lesson, we have learned about receiving the data in a Spark Streaming application and how it launches tasks in batches in a Spark Streaming cluster. We also had an overall look at a Spark Streaming application. That's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.